All right, here we go. Unit 3, Objective 2. We're going to start graphing polynomial functions, okay? So we learned all about polynomial functions, odds and evens, pay attention to the degree. So here's a little summary of what we learned in the previous objective, okay? We need to know the if we have an odd degree function or an even degree function. That's the first thing we want to check to see what kind of function we have. The degree determines the shape of the function. And then we also want to know, the second information we want to know if it is, do we have a positive leading coefficient or a negative leading coefficient, okay? So two things we need to focus on is the degree of the function, and then if it is positive coefficient or leading or negative leading coefficient. So if it's even, we also have to check if it's positive leading coefficient or negative leading coefficient. So those are the pieces of information we want to focus on every time a function is given to us. Today, we're going to look at the functions not in standard form. We're going to look at them in factored form. Let me do a quick refresh in your mind here. The previous objective, okay, this is the notes from the previous objective. You should have your notes with you. This number one example right here is in standard form, okay? This right here is in standard form. It's not factored at all right? And number two is also in standard form. We're looking for the degree of the function, okay, and so forth. Those are all in standard form. Number three, we're in standard form, okay? Then we played around over here at the end of the notes. We saw some that were partially factored, okay? We saw one factored and one trinomial, and then this one was completely factored. So today we're focusing on this kind of polynomials that are already factored completely. So if you need to take a break, pause it for a second and look at your previous notes. We want to focus on factored polynomials that are factored, okay? All right, so what are we looking for today? Well, today we're going to look for finding the x-intercept of the polynomial. If I want the x-intercept, I will let the y equal 0. Okay, I'll set the y to be 0. So if I want the x, I set the y to be 0. So let me put that little highlight right here. So if I want the x-intercept, I set the y to be 0 and solve for x. Now, if we have a factor, okay, a factor x minus c, c is a constant. If x minus c is a factor of a function f of x, then that c value, that constant, is an x-intercept, okay? I know it doesn't make a whole lot of sense when we do a definition like this, but when you see in numbers, I will try to refer back to here what this is saying, okay? Not every polynomial has an x-intercept, okay? I can have a function, not an odd but an even function that completely has no x-intercept, and I will go over that when we get there. Finding the y-intercept. Well, now I want the y. If I want the y, then I let the x be 0. I set the x to be 0, and then I solve for y. Okay, so that's what we need to put in our minds. If I want x, I set y to be 0 and solve for x. If I want the y, I set x to be 0 and I solve for y. You always want to solve for what you want, and then the other variable that you don't want, you set it to be 0, okay? So the point 0, comma f of 0, meaning I plug in a 0 for x and I solved for the y, is the y-intercept of the polynomial, okay? What is multiplicity? This is a new word for you, okay, that you haven't heard before. Multiplicity of an x-intercept is the number of times a factor occurs, okay? So, for example, if I have x minus 3 2 times, then I say that that x-intercept has multiplicity of 2. So, is how many times the x-intercept occurs, okay? I will repeat this information here as we are solving it, okay? All right, so let's do it with numbers. This is in English, a definition of what is going on, but let's do it with actual numbers, all right? So, here we go. Find the x and the y-intercept and state the multiplicity of the following polynomial functions, okay? So let me go ahead and separate here because I write big and I want to put a division there. Okay, so y equals x squared times the quantity x minus 4 times the quantity x plus 5. I have three separate factors. I have this factor, I have this factor, and I have this factor. Okay, so I have three separate factors. So if I have a factor, if I want to solve for x, I let the y be 0. So before I do that, let's do something really quick. I know it's not telling me to do that here, but take a look at the function and let's decide what kind of function we have. I know I'm going against the instructions here, but just stay with me here for a second. In your previous objective, we decide what kind of function we have. We have to determine the degree. Let me just write over here, degree. Okay? So if I grab the x values only, okay, I'm going to do it on the scratch paper on the side, right here. If I grab the x values only, so I have a x squared times, there's an x in this parenthesis right here, and then I have another x in this other parenthesis right here. So I actually have three x's. One of them is squared. If I multiply x squared times x to the first times x to the first, we have x to the fourth. There's a rule of exponent that says when you multiply the bases, you add the exponents. So we have x to the fourth. So we have a fourth degree polynomial. That's even, okay? That's an even polynomial. So it's going to look like one of these right here. We're not graphing it yet, but I just want you to start practicing from beginning to end, okay? Can we talk about leading coefficient? Because these two pieces of information are important. Well, there's an invisible number 1 right here. The leading coefficient is a number 1, which is positive. We just want to know if it's positive or negative. Okay? So let's get in the habit of doing this because it helps us determine the shape of the function. Okay? Eventually we want to know how to graph it. Right now we're just practicing finding the x-intercept and the y-intercept. And then we want to state the multiplicity, how many times the x-intercept appears. Okay? All right, so let's go back to the instructions. So if I want the x, I will set the y to be 0. So I'm going to put right here, I'm searching for the x-intercept. Okay, that's what I'm searching for. I'm going to go ahead and write the same exact function, but in the place of a y, I'm going to put a 0. 0 equals x squared times the quantity of x minus 4 times the quantity of x plus 5. There's a rule that says that we can set each of the factors equal to 0 so we can solve for x. Okay? So I'm going to set the x squared equal to 0. I'm going to set the x minus 4 equal to 0. And I'm going to set the x plus 5 equal to 0. I'm solving for x. Okay? Now, anything squared means that there's two of them. Okay? I'll recap that with you if that doesn't make sense. For example, 2 squared, it just means that there's 2 times 2. There's 2 of the number 2. 3 squared is 3 times 3. Okay? Well, x squared is just x times x. So I actually have 2 of the x's. Okay? So when I see x squared over here, I have 2 of those. I have an x times an x equals 0. 2 of them. So that means I have 2 factors equal to 0. So I set each of them separately equal to 0. All right? So anything that's squared is happening twice. So there it is, x times x. I set each of them equal to 0. I solved for x. There's 2 of them. Now let's go back and solve for this other factor over here. X minus 4 equals 0. All I have to do is add a 4. So I can get my x by itself. And I get that x equals 4. There we go. I solved for that other factor. Now, the x plus 5 equals 0. We subtract 5 to the other side. We do the opposite operation. And we get x equals negative 5. So there goes my other one. So I solve for the x-intercept. It says find the x and the y-intercept and state the multiplicity of the x. Okay, so when we're talking about multiplicity of x-intercept is the number of times a factor occurs. Okay, so these are the factors or the zeros. So this occurred twice. So this is multiplicity 2. I have 2 of the same value, which is 0. This one is multiplicity. I'm just going to write M for multiplicity, 1. And this one, I only have one answer, x minus x equals -5, so it's multiplicity 1. So multiplicity 1 is because I only have this answer one time. Multiplicity 2 is because I have this answer twice. Now the last thing I need to do is find the x-intercept. Check, I did it. Find the y-intercept. So let's see if there's room here to find the y. Okay, now I want the y-intercept. To solve for the y, I replace the x's with 0. So let me see if there's room over here. I'm going to try to squeeze it. Okay, it's going to be the same exact function, the same exact polynomial. Y equals 0 squared times 0 minus 4 times 0 plus 5. Oh, see, I crossed my little line over there. Okay, 0 plus 5. Okay, so let's keep solving. Y equals, what's 0 squared? 0. 0 minus 4, it's just minus 4. 0 plus 5 is just positive 5. Okay, now if you multiply all this, 0 times anything, okay, 0 times -4 is 0. And then 0 times 5 is 0. So 0 times anything here is going to be 0. So our y-intercept is 0. Okay? All right, let's do the same exact thing again, finding the multiplicity of the x's, finding the y-intercept. Again, we have y equals 2 times the quantity x minus 1 squared. Anything squared, that tells me that happens twice, so I have 2 of these. And then I have a 3 minus x. Let's solve for the x-intercept first. Okay? I skipped this part over here, determining the degree, the leading coefficient. Maybe you want to do it on the side. Pause the video and do it by yourself. We will start doing it again the next page. All right, so x-intercept. Well, if I want the x, I'll make the y be 0. So the same exact function, I'm going to set the y to be 0. 0 equals 2 times the x minus 1 squared times the quantity of 3 minus x. I'm going to set each of the factors. I have 3 factors. I have the 2, the x minus 1, and the 3 minus x. I actually have 4 because the x minus 1 happens twice. So let's go ahead and set each of these factors, the 2, the x minus 1, there's 2 of them, and the 3 minus x. So 0 equals 2. That makes no sense. That's a false statement. Okay, that's false, so we can throw it in the garbage. And by the way, we're solving for x anyway, and this number 2 had no x involved in it. That's why it gives us a false statement. The x minus 1, it's a squared, so I'm going to write 2 of them separately. X minus 1 equals 0. X minus 1, I don't need the parentheses. I don't know why I put parentheses on this one. And then I have the 3 minus x equals 0. Okay, so I set each of my factors equal to 0. This one made no sense. 0 does not equal 2. Okay, now let's solve for each of them. Well, all I have to do is add 1. We do the opposite of what we see here. So x equals 1. Here's one factor. Add 1 again to this other one. X equals 1 again. And then this one, let's do it carefully, okay? This nice little factor came in kind of like not in the order that we used to see. So let's subtract the 3 first, and we get a negative x equals negative 3. And then to get rid of the negative right here, there's an invisible negative 1 in the front. We just need to divide by a negative 1. Okay? So x equals positive 3, because a negative divided by a negative is positive. Now let's talk about the multiplicity. How many times do you see a certain answer? I see this answer twice. So x equals 1, multiplicity 2 tells me I see this answer twice. Okay, so I just said, here we go. And then x equals 3 is just multiplicity 1. So the students at this point, they start realizing, Mrs. Myers, so every time something is squared is multiplicity 2? Yes, that is a good conclusion. Every time something is squared is multiplicity 2 because it's happening twice. Okay, even if it's just x by itself, it ends up being multiplicity 2. So if that is the conclusion you made, good job. Now, what are we missing? The y-intercept. So if I want the y, let me do it in blue right here, the y-intercept. If I want the y, I'm going to set the x to be zeros. Okay, y equals 2 times 0 minus 1 squared and 3 minus 0. Okay, let me move to another piece of paper because I can't handle working on small spaces like that. So I have y equals 2 times 0 minus 1 squared times 3 minus 0. Let's solve for that. Y equals 2 times 0 minus 1 is just negative 1 squared. So negative 1 squared. And 3 minus 0 is just 3. Now this is all multiplication, but let's take care of the exponent first. Okay, it's just order of operation. 2 times negative 1 squared is just negative 1 times negative 1, which becomes 1 times the 3. Multiply it carefully. Whoops. Y equals 2 times 1 is 2 times 3 is a 6. 2 times 1 is 2 times 3 is a 6. So our y-intercept, after we do this calculation here carefully, is 6. All right. So I plug in a 0 for x and I got a 0 for y. All right. That's how we find the x and the y intercepts. So at the bottom of the page over here, it's giving us a little bit more information about multiplicity. Multiplicity. If the multiplicity of the x-intercept is odd, like number 1 is odd, okay, multiplicity 1, the number 1 is odd. So if the multiplicity of the x-intercept is odd, then the graph of the polynomial passes through the x-intercept, okay, passes through the x-axis at the x-intercept. So if the multiplicity is 1, we pass through the x-axis. If the multiplicity is even, like the number 2 is even, then the graph of the polynomial bounces or touches. What does bounce mean? Bounce is like when you hit it and you come back up, okay? So it's a bounce. It bounces the x-intercept at the x, I'm sorry, I keep saying it wrong. It bounces at the x-axis at the x-intercept, okay? So when I look at this graph over here, this is a bounce. Okay, that's a bounce. It came from the bottom, it hit it, and then it kept on going down. So it bounced over here. This over here, you cross the x-intercept, the x-axis. Over here, you bounced. You came from up here, and then you bounce here, and you continue going up. So that's a bounce. Let's write bounce over here. Over here is a cross. We crossed the x-axis. So what that tells me is if I cross the x-axis, it was the multiplicity was odd, some odd number, probably the number 1. If it bounced, the multiplicity was even. If it crossed, was the multiplicity odd. If it bounced, the multiplicity was even. Okay? Now that we know this bounce, that's the reason why we're doing the multiplicity, the bouncing and the crossing. Now we can do a problem from beginning to end to graph it. Okay? So let's try right here. So we have sketch the graph of the polynomial function, label the x and the y-intercept here on the grid, and let's follow the step-by-step instructions here. Okay, so it says, first, find the x-intercept and multiplicity of the function. I'm going to break my rules over here one more time. I'll come back to this in just a minute, I promise. What I want to do is determine the degree of the function and then the leading coefficient, just like I practiced with you on the very first example I did. Okay? So I write big, that's why I always need more room over here. So let me grab a scratch paper. All right, so here we go. When I see this function over here, I'm looking for the x value so I can determine the degree, okay? So I see that there's a x plus 3 squared, so that means there's 2 of them. There's an x plus 3 times an x plus 3. Yes, you can put your leading coefficient there. And then I have an x minus 4. So if you have something that happens twice, it's good to write it out. So I'm looking for the degree, so I only look for the x's. There's 1x times, here's another one, times, here's another one. Okay, none of them are squared. I took care of the square by separating them. So when I multiply this, x to the first times x to the first times x to the first is x to the third. That's the degree of the function. It's degree 3, which is odd. Okay? And then we look at the leading coefficient, which is obvious to us, it's not invisible. It's actually very visible, is the number 2. So the leading coefficient is 2, which is positive. Let's just talk about the shape of the function before we actually start following these steps over here. Okay? An odd positive. Take a look at your picture that we did just a second ago here on your notes. An odd degree, but positive leading coefficient is going to look like this. So I already know what my graph is going to look like. Let me just do a little drawing right here. It's going to look like that. Okay? Just based on this right here. Okay. Now I'm ready to follow the steps. Find the x-intercept and the multiplicity of the x-intercept. So we want the x-intercept. So I'm going to set the y to be 0. The f of x represents y. We're going to set that equal to 0. 0 equals 2 times x plus 3 squared times x minus 4, quantity x minus 4. Let's set each of those factors equal to 0. There's one factor, x plus 3 happens twice, and x minus 4 happens once. 2 equals 0 is a false statement. We can throw it away. X plus 3, you can do it twice, or you can just do it once. It's up to you. Okay? It equals 0. And then you have your x minus 4 equals 0. So those are the 3 separate factors. You can solve it just once. Okay? X plus 3 equals 0. X equals negative 3 because you subtract to the other side. Multiplicity 2. Why is multiplicity 2? Because there was 2 of them. You can work both of them separately, or you can save yourself time and just remember there's 2. That's why it's multiplicity 2. Okay? So x minus 3 multiplicity 2. This one is a false statement. We don't need it. And then this one, when I add a 4 to the other side, x equals 4 with multiplicity 1. Okay? So what does this multiplicities tell me? I'll go back here to the previous page. It says, if the multiplicity is odd, it passes through. If the multiplicity is even, an even number, it bounces. So let's write that here. The number 2 for this multiplicity is even, so it bounces. The number 1 here is odd for this multiplicity, so it crosses. Okay, we need to know that. So we're ready to graph this example right here, this graph. We need the y-intercept. Thank goodness there's lots of room in this paper for me. Okay. The y-intercept, if I want the y, I set the axis to be 0. So y equals 2 times 0 plus 3 squared times 0 minus 4. Okay, let's do it carefully, order of operation. Y equals 2 times 0 plus 3 is just 3. Don't forget it to square. And 0 minus 4 is just a negative 4. We always do PEMDAS, okay? P, PEM, DAS. Parentheses, yes, I did take care of the parentheses. Now is exponent. Let's take care of the exponent. Y equals 2 times. 3 squared is a 9. It's 3 times 3. And then negative 4. There we go. Now we can just do multiplication. Multiply all of them. Negative 4 times a 9 is negative 36. Negative 36 times a 2 is negative 72. So my y-intercept is, when I'm going to do it in order pair, right here. When I plug in 0 for the x's, we got a negative 72 for an answer. That's our y-intercept. Okay? We plugged in a 0 for x, we got negative 72. Now I have enough information. I know what kind of graph I'm doing. I know where it touches on the x-axis. I know where it touches on the y-axis. I have all this information. Let's start putting things here on the graph. So x equals -3. 1, 2, 3 right here, -3. That's one of my x-intercepts. I'm going to put a little b to tell me that it bounces. X equals 4. 1, 2, 3, 4. Let me label. Put a bubble there. It tells me that I'm going to cross there. So we find the x-intercept in the multiplicity. We find the y-intercept. We find the degree and the sign of the leading coefficient. That's what we did first. I broke my rule here. Make a basic sketch based on the end behavior. So we have a basic sketch right here based on the end behavior. That's what we did right here. And then let's graph it, okay? It says plot the intercepts first. So I put my -3 with the bounce. I put a 4 with the C. Put B by the bounce and put C by the cross. Sketch the continuous function, but let's go ahead and also put the y-intercept. I'm not going to make 72 tally marks here because that is ridiculous. I'm just going to make a mark right here, and I'm going to label -72. It's negative, so it has to be down here on the bottom. So my graph bounces off of here, crosses the y-intercept, and crosses that number 4. Let's mimic that shape. The end behavior starts from the bottom, and it's going to end up here. So I'm going to bounce on the -3. Don't cross it, just bounce. Just touch it and then bounce down. Come to the y-intercept, cross the 4, and go up. That's the end behavior. We started at -infinity, and we end up going to positive infinity, the end behavior that we practiced before. Okay? And that's how you graph a polynomial from beginning to end, finding the x-intercepts, finding the y-intercepts, understanding the degree and the leading coefficient and the general shape. Okay? All right, let's do it one more time, just to make sure we get it 100%, and then I'll let you do the other 2 by yourself. Okay? All right, I'm breaking the rules here. I'm sorry. I usually try to follow the rules, but I like to do the number 3 and the number 4 first. I like to decide what kind of function I have in my mind, so I can at least try to do the best I can with the shape, okay? So let's look over here, and let's determine the degree of the function, the degree, and the leading coefficient. Those are the 2 things we want to determine first. So take a look at what you have here. The leading coefficient is this invisible -1 in the front. So we can write -1, which is negative, right? Now let's determine the degree. We look at the axis, okay? So let me go ahead and grab a piece of paper right here. So I have x minus 4 twice because it's squared. And then we have x plus 1 also twice because it's squared. Now, if you just ignore the numbers, ignore the -4, the plus 1, and only focus on the axis, okay? And you multiply x times x times x times x. When the bases are the same, what do we do to the exponent? We just add the exponents, x to the 4th, okay? So the degree is 4, which is even. One of my students said, Mrs. Myers, could I just add this 2 plus 2 equals 4? Yes, you could have done that, okay? I could have done that in the beginning over here. Look, there was a squared plus an invisible 1 over here, okay? 2 plus 1 makes 3. That's 2 of these factors plus 1 of this factor. So there's 3 x's that I would be multiplying together. So if you start making those conclusions, good job, okay? All right, so the degree is even. The leading coefficient is negative. Go look at your shape. Go look at the shape on the previous page. We have a negative even function. It's going to look like this. The end behavior both go down with some wiggle in the middle. Looks like the M shape, right? So the end behavior is going down to -infinity on both sides. So that's the kind of shape we're going to be doing right here. Okay? Let's work on the x-intercepts. So x-intercepts is what I want first. If I want the x, I'm going to make the f of x, which is the y, be 0. 0 equals negative invisible 1 times x minus 4 squared, meaning it happens twice. And x plus 1, the quantity x plus 1 squared, that means it happens twice. So we set each of the factors equal to 0, including this invisible 1 right here. Okay? So 0 equals negative 1. That's a false statement. False. The x minus 4, remember, is a squared, equals 0. And the x plus 1 squared equals 0. So if you want to conclude, Mrs. Myers, since it's a square, the multiplicity is going to be 2, right? Yes, the multiplicity is going to be 2. For this one as well? Yes, for this one as well. The multiplicity will be 2. Then you just have to solve it one time. X minus 4 equals 0. You add the 4 to the other side. Add the 4. So you get x equals 4. So there's your multiplicity, your x-intercept with the multiplicity. So the multiplicity is 2. We already took care of that. Because it's a square, the multiplicity is 2. Because this was a square, the multiplicity was 2. There was 2 of them. I'm doing the work for 1, but I know there was 2 of them. So x plus 1 equals 0. Subtract the 1, and you get x equals negative 1. So negative 1, multiplicity 2, positive 4, multiplicity 2. So guess what's going to happen on both of those? It's going to bounce because it's an even multiplicity. The number 2 is even. Okay, we're almost done. We know the shape. We know the x-intercepts. We need to know the y-intercept. I'm going to do it here. The y-intercept. Okay, if I want the y, then I make the axis 0. Y equals the negative 1 times 0 minus 4 squared times 0 plus 1 squared. Okay, we're going to obey PEMDAS. Okay, take care of the parenthesis first. Inside of the parenthesis, y equals negative 1. Inside of the parenthesis, 0 minus 4 is just negative 4 squared. 0 plus 1 is just 1 squared. All right, so negative 1 times negative 4 squared times 1 squared. What's negative 4 squared? Negative 4 times negative 4 is 16. So we have, I'm going to go down here. So we have y equals negative 1. The negative 4 squared is 16. The 1 squared is 1. So negative 1 times 16 is negative 16. Negative 16 times 1 is negative 16. So the answer is negative 16. Let's write as an order pair. We plug in 0 for x. We got negative 16 for the y. There is our y-intercept. Okay, lots of work. Try to be a little bit more organized than me here. For some reason today I'm all over the place. Okay, let's go ahead and put all this information together. X equals 4. 1, 2, 3, 4, right here. 4. 1, 2, 3, 4. Let's put a little x-intercept. Let's put a little b for bounce. Negative 1 is right here. Let's label negative 1. Let's put a little b for bounce. Let's put negative 16 down here. Negative 16. We know that that's our y-intercept. And we're going to make this shape right here happen. Okay? From the bottom, we're going to bounce, come to the y-intercept, go bounce, and the end behavior is going down to negative infinity forever. There we go. And that is how you graph it. Okay? I like to start with this right here. Because if I mess up on something over here, then I'm like, okay, why am I not getting the right shape? I messed up somewhere over here. Okay? So I have time. I try to keep the videos no longer than 40 minutes, 30 to 40 minutes. So I'm going to do one more. Okay? Just if you don't need it anymore, you can stop the video, but I'm going to do it one more time. I want to see an odd function. Okay? So here we go. Let's do this one. I will do this one, and then you can do this other one. All right. So let's start doing a few shortcuts. Maybe a few shortcuts will help you. I have x squared, so there's the exponent right there. This factor only happens once. And this x plus 2 only happens once. So the degree of the function is the exponents added together. 2 plus 1 is 3, plus 1 more is 4. So the degree is 4. It's even. The leading coefficient. Well, there's an invisible number 1 in front of this x squared, so it's just a 1 and it's positive. So a positive even is a W shape like this, okay? The end behavior goes up to positive infinity. There we go. So we know the shape, we know it's even. Let's find the x-intercepts and the y-intercept, okay? So let's go ahead and find the x-intercept up here, x-intercept. Let's set each of the factors equal to 0. X squared equals 0. X minus 1 equals 0. X plus 2 equals 0. So now I'm going to start using little shortcuts here because I explained everything in details before. Because x is a square, that means there's 2 of them. The multiplicity is 2. Okay, multiplicity 2. I'm going to solve it only once. X equals 0. I only see this answer once, so the multiplicity will be 1. X equals, when you add the 1 to the other side, x equals 1. I only see this factor once, so the multiplicity is going to be 1. And if I subtract the 2 to the other side, x equals negative 2. So those are my x-intercepts. It's going to cross on this 2 because the multiplicity is 1, but it's going to bounce here on this 1 because it's multiplicity 2. Almost done. Let's find the y-intercept down here. Okay, the y-intercept. Let's set the x's to be 0. Y equals 0 squared times 0 minus 1 times 0 plus 2. Okay, let's follow PEMDA's order of operation here. 0 squared is 0. 0 minus 1 is minus 1. And 0 plus 2 is positive 2. Okay, well, 0 times anything here, okay, 0 times negative 1 times 2 is just going to be 0. There we go. So let's write as an order pair. We plug in 0 for x, we got out a 0 for y, 0, 0. Okay, that's our y-intercept right here. Now let's put all this information together. At 0 right here, we're going to bounce. Let's put a little b for bounce. It happens to be our y-intercept as well. Okay, it's our x-intercept and y-intercept. There we go. 1 right next to it, and we're crossing. And then the negative 2 right over here, negative 2, and we are also crossing. So there's a cross, a bounce, and a cross. So let's try to mimic the same exact shape right here. The end behavior has to end up going to positive infinity. So we're going to cross at the 2, cross at the negative 2, and then we're going to bounce off the 0, 0, and we're going to cross back up. I missed my little arrow. Okay, there we go. So we crossed, we bounced, we crossed. There we go. It's so helpful to know the shape before we even start drawing, solving, okay? So it's so helpful to know the shape. I want you to try this one right here. And if I would like for you to try it, so when you come to class, you can be like, okay, Ms. Myers, can you do letter B one more time just to check to see if I did it right? And then you'll be successful in class if you know how to do B by yourself, okay? Good job, guys. 38 minutes. I try to finish under 40. Good job.